How are you guys? Today our topic is related LV panel inspections and devices which is inside of our LV panel, and we are include also our lighting inspections, pre-commissionings and visual check, and to do the testing. What is the procedures and how we will check. So by the way, my name is Rente Cristo. For those new in my channel, don't forget is like and subscribe and click the bell button so that you will be notified during all of my uploaded videos. So we can see, as always guys, the presentations every week related our E&I and telecommunications related my works activities. Shall we proceed? This is our LB enclosure guys. As you can see here, very clear what is there inside. There is a bus bar. You can see red, yellow, or green or blue. That is RYB. Okay, so meaning this is our bus bar, and then we have our circuit breaker and then wiring connection. So first, our thermostat. So what is the thermostat guys? You can see here different models that you can see 011, see KTS 011, KTO 011. So that is different purposes, as you can see. So what is the thermostat guys? Thermostat is contact breaker to regulating heaters, and then regulating filters, fans, and temperature limit has been exceeded. That is, we need to adjust our thermostat. It depends when and where. So for example, you want to do let's say to setting 20 degrees, 20 or 30 or 25. So that's the time where the heaters will be start. Okay, so this is another one, electronic hydrostat. Okay, the wiring, you can see the wiring from the heater itself, neutral line, and then 1 to 5, and then this is how you connect going to our heater. So example connections guys, that one. So electronic hydrostat sends the relative humidity in an enclosure with electronic component. So we have a different purposes. That's why we need to explain this here. So why we are using this. Okay. So LED integrated in the adjustment knob is lit when the connected heater is in operation. Okay. So disconnecting fuses. Basically, those who knows already, who those familiars with the panels, construction activities at site. So I'm sure you are all familiar. So disconnecting fuse terminal, fade through terminals, disconnecting terminals. These are different kinds of terminals. So fade through terminals, as you can see, this is the example. So now we'll move on to our meter and selector switch. So this is our selector switch. Applications suitable for panel builders requiring a panel mounted switch for switching meter between phase current or line and phase voltages. So this is our circuit breaker. So familiar our circuit breaker, correct? This is only the sample guys. Our circuit breaker MCB is 200, and then if you are going for inspections or checking the breaker rating, you can see here the red, the green color that I write it there, rating amps 10 amperes. Okay, you can see there C10, that is his rating of the breaker. So if you can see here 63, so meaning that is 63 amps. If you can see 6. So C6 meaning that is 6 amps. Okay, contact position indications, identify on and off position. You can see off, and then you can see also off, on. Okay, so we have different auxiliary contact element for the breaker. We have RCD, RCBB, RCBO, AFDD. So this is the functions. Circuit breaker, CB, that is the definitions. MCB, miniature circuit breaker. MCCB, molded case circuit breaker. RCCB, residual current circuit breaker. And so on and so forth, guys. Okay, this is our abbreviations. Then auxiliary relays. So you can see the auxiliary relay. So this is the cycle or the loop of the purpose of your auxiliary relays or other relays as well. So interface relay, we are widely used in various industrial applications. That is what we call interfacing through our electronics and controlling for our PLC, program logic controller, or either field bus or any sensors. Okay, so this is our rating: 16 amps, 250 volts. By the way, we have a lot of different kinds of relays. Huh? See, this is the exploded view. So complete variations of our relays: 24 volts, AC/DC, 110 volts, AC/DC 230. So different coil voltage. So this is our different coil voltage and the versions of voltage. Different output. So we have a different output of our relays. You can see different output. One output contact 16 amps, or two output contact 8 amps. Then we have 10 amps as well. So now we'll proceed to photocell. So what is the photocell? Electronics and light sensitive sensor are encapsulated in a flame-proof alloy enclosure with this M32, that is our gland, and this is the size of our cable, 1.5 threaded connections, encapsulated connections, cables 500 mm long, and photocell has an electronic circuit with a low power consumption, guys, that is 1 watts, 1 W, and voltage range 100 volts to 260 volts. Okay, that is a current rating of 10 amps. So the electronic switches on immediately if the light falls below the threshold values, and then 2 to 5 seconds switching off delay to avoid accidental switching due to light flashes. So that is our purpose of our photocell. So yan ang mga ginagawa natin usually sa ating installations. Okay? So earth leakage relay variable. So this is the settings and connections diagram for your idea. And then technical specification of our earth leakage relay. And then the frequency range, and also our voltage rating and watts. Okay, so how about our CT? What that is current transformer. So we have also a current transformer in our panel. So we have current ratios 1 is to 1000 maximum, that is primary and secondary, for example, guys. And then permissible current 1 kA, 1, and then continuous 5 to 1.5 seconds, that is for tripping, guys, seconds. So this is how you install, guys, for our CT. So you can see the X here in the third photos. They are putting X, so meaning this is wrong installations. And that the first one, In figure 1 and figure 2, this is the correct installations of your CT. So these are different kinds of CT that you can see in our installations in oil and gas industry. So we can see this one. And then now types of auxiliary contact blocks, contactor, let's say. So we have different contactors, control relays. So this is our scheme for showing our contactor going to our accessories, and we have a different scheme here. It depends of the design. So auxiliary contact blocks are used in the operations of auxiliary circuits to control circuits, standard industrial environment. So contactor, control, relays. So meaning you need to control. Okay. So we have mechanical and interlocking. So now we are going for inspections and verification of our lighting circuits. So distribution board, type of protections, layout drawing, protections rating, voltage rating, circuit load, and wiring diagram. When you do the inspections, verifications, you need to verify this. So is this correct? The type protections correct, rating is correct. Based on this, all the drawings, guys. Okay, this is your verification purposes during your inspection. Of course, when you do the testing, you are required any test instrument like sample, multimeter, meter. Okay, this is mostly common for our testing, especially our electrical testing. Okay, so number of pictures, number of GB, how many, and then pictures tag number. For example, how many lights that you installed, how many circuits that you installed. So this must be informations here. So type of fittings, installation results, GB tag number, type of GB, test results. So during your continuity test and meter testing, so PE and NE, so protective earth, neutral earth. So inspection, verifications, lighting circuits. For example, when you are checking the lighting circuits, check the circuit is de-energized first. This is our safety first. And then check luminaires, socket, rating, tag against drawing. Check luminaires, socket are correctly mounted, accessible. So if this is not accessible from your side, don't do inspections. Don't do any actions without this accessible. This is safety concern, guys. Okay. So check luminaires, socket, junction box are undamaged. Check luminaires, junction box, socket. Check all unused entries, junction box. If there is an open hole in your panel, so provide dummy plug, approved plug that you need to provide as the contractor. If you are the main contractor or subcontractor, you need to provide this. Okay. Check cable glands mounting and compliance with the specifications. Check cable for proper connections. This is how you inspect for the lighting. Basically, this is a normal inspections. This is the normal requirements during your inspections, guys. Check earthing and bonding against drawing. This is the important also. Verify the earthing is there and bonding. Check circuit breaker rating. This is the also checking what is the rating as per drawing requirement. And then after that, if there is deviation, so for example, when you do the inspections, the rating is changed. For example, from 6 amps to 10 amps, yeah, you need to do red line markup and query to our engineering. head office. Okay, so this is the example of our switchgear feeder. This is a single line diagram. You can see from the switchgear feeder going to our panel, and then in the low side you can see this is going to our loads. So how many lights, how many sockets. Okay, this is our single line diagram. So when you do the inspections, so for those example here, see you can see 1R. So this is single number one, and then Y number two, and then B RYB. So meaning this is your single breaker. So RYB. Okay, this is your connections. Single phase, another Y single phase, and B is single phase. And then how much the load, you can see it here. How much the rating of the breaker. So this is the example. When you do the inspection, you need to check as well the connection is correct. How many illuminators, how many lights, how many bulbs. It's 1 GB and 5 lights. So how much the rating of the breaker. You can see the example of the actual example, guys, from the main breaker. Okay, this is the connections, wiring. Then this is the panel. This is the bus connections, contactor, breaker, wiring. Example lighting and small power layout. So this is our example, guys, for the layout of our lighting. So when you are do the verification checking the lighting, so is this correct layout? So correct elevations, you need to check the elevations, the height, wherein the locations of your lights and junction box and switches, emergency light, and so on and so forth. So this is our example of our exit light, explosion proof, okay, proof lighting. So we have here EXD and zone, and this is a temperature, zone 1 and zone 2, class divisions. So this is the information, guys, during uh, our project. So inspection and testing for lighting small power circuit. This is how we do the testing. Confirm light circuit is complete and installed according to layout drawings. Confirm circuit as built single line diagram layout. Confirm all equipment certified suitable for area installations. Check and record installation resistance. Circuit. After you complete your continuity and major testing, you need to record. Okay, and then submit and signature by the company and contractor, subcontractor as well. That is proceeding for our mechanical completions. Check and confirm the polarity of the circuit, check record circuit voltage, and set it, etc. So, testing and measurement, instrument use, calibration certificate, validity, and record sheet. So this is how you do the inspection, guys. Okay? So testing, commissioning testing. So this is our format when you do the commissioning testing. Distribution board reference, lighting layout reference. You need to write it there. Your what is the drawing number, what is the panel number, what is the circuit and illuminations, and then how much, where is the area, and how much the lux that is required as per our specification requirements, and then serial number, test point, descriptions, all of that. So type of model, what is your testing measurement, type model, serial, calibration certificate, and validity. This is our format during our commissioning testing of all lights. lighting fixtures. So thank you guys, and thank you for all your support. See you in my next video uploaded this coming week again. So we'll see you guys and have a good day. Bye bye.